Good day, grade 10 learners. We are now in week 3 of our third quarter, and the topic is illustrating combination of objects. I hope you will learn a lot for today's lesson. For this week, the learning competency is to illustrate the combination of objects. At the end of the topic, the students are expected to number 1, define combination. Number 2, determine if a given situation shows combination or not. And lastly, find the number of combinations using the appropriate formula. Now, let us discuss what is combination. When we say combination, it is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the collection does not matter. Remember, order does not matter. In real-life situations, sometimes when we arrange, order is important and sometimes it is not. Let us consider this activity. Type yes on the comment box if order is important and no if the order is not important. Winning in a competition. In a competition, it is important that we have the first, the second, and the third winners. So therefore, the answer is yes. Order is important. Next, selecting 8 students to form the mathematical society. So in selecting the president, the vice president, and so on, it doesn't matter who will be the first student will be elected. Therefore, the answer is no. The order is not important. The third one, forming triangle from 5 distinct points in which no 3 points are collinear. When we are forming triangles, it is not important which of the 3 points are selected in order to form it. Therefore, order is not important. The answer is no. Next, opening a lock with a combination. Although there is the word combination, it doesn't mean that order is not important here. In order to open the lock, there is only one specific code that we can use in order to open it. Therefore, the answer is yes. Order is important. Last situation, choosing 5 out of 10 questions in an interview. So when we choose 5 questions, it doesn't matter which will be the first question. In this situation, order is not important, so the answer is no. How to find combination of objects? The number of combinations of n things taken r at a time is written as C of nr or NCR. The formula is given by C of nr is equal to n factorial all over r factorial times n minus r factorial, where r is greater than or equals to 0 but less than or equals to n. Remember class, n should be greater or equal to r. Let's have some sample problems. Example number 1. In how many ways can a PE coach choose 3 swimmers from among 5 swimmers? In this situation, the total number of swimmers is 5, so your n is equal to 5. Your r is equal to 3. By using the formula, C of nr is equal to n factorial all over r factorial times n minus r factorial, let us substitute n and r. So we have C of 5, 3, which is equal to 5 factorial all over 3 factorials times 5 minus 3 factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 5 minus 3 is equals to 2 and 2 factorial is equal to 2 times 1. By cancelling the common terms in both numerator and denominator, The remaining factors in the numerator is 5 times 4, and that is equal to 20. In the denominator, we have only 2 times 1, and that is equal to 2. 20 divided by 2 is 10. Therefore, C of 5, 3 is equal to 10. So, C of 5, 3 is equal to 10. Example number 2. A committee of 5 people is to be chosen from a group of 6 men and 4 women. How many committees are possible if there are no restrictions? Since there are 6 men and 4 women, the total of people here is 10. So in this problem, n is equal to 10 and r is equal to 5. By substituting n and r to our given formula, C of nr equals n factorial all over r factorial times n minus r factorial. We have 10 factorial all over 5 factorial times 10 minus 5 factorial. 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. 10 minus 5 is also 5 factorial. So we still multiply 5 factorial by another 5 factorial, which is also equal to 5 times 4 times 3 times 2 times 1. By canceling the common factors in both numerator and denominator, 10 times 9 times 8 times 7 times 6 is equal to 30,240, and 5 times 4 times 3 times 2 times 1 is equal to 120. 30,240 divided by 120 is equal to 252. Therefore, the number of combinations in this problem is 252. Thank you, learners, for listening. Until next time.